Hey everybody, welcome back. I think I just said hey everybody. That was weird. Um, what's going on? I am sweaty, as you can see. Why change my shirt? Why would I do that? No, I was kind of a little bit rushing over here. We just had dinner, and before that, I was, man, did a bunch of stuff outside today. Let's see. We had to, well, I always have to feed the horses and put out the hay for them and the cows. Um, we also have to feed the horses another like their horse food or whatever. I don't do that part, but I put out the hay. And I typically so we have a bunch of chickens. We've got pigs, we've got cows, and we've got horses and ducks. Although the ducks are pretty low maintenance. And we have guineas now too. We've got like 16 or so guineas, and they're kind of like chickens, but they tend to all move in like a big flock and they don't really fly around very much. But they're good for ticks. So if you live in Texas, it's probably a good time to get some guineas because we've definitely been finding ticks all over. Like the dog's been bringing them in, and I've been finding them on my legs. So anyway, so we got some guineas. We used to have them a long time ago. Well, not a long time ago, like 4 years ago or so. But um, they get picked off by predators because they don't really go into a coop. They just kind of go in the trees and stuff, I guess. So, anyways, we've got the pigs. I have to feed them at night, and the chickens. Usually, we get the eggs from one of the coops, and then we have a bunch of different ages of chickens that we raised from. We have some that we raised from eggs, like our own eggs that we hatched, and so we got to take care of them. And then also we've got the ducks. We bought some ducks at the local feed store, along with some guineas that we got in the mail. So they're being raised together in one of the other coops because they're not really old enough to go out completely, but they're not so young they need to be like in a little brooder. So you feed them, get their water and everything. And then we also have a bunch of chickens out on the pasture in a mobile coop. And so, but I usually do those guys in the morning, and then after I'm done with the stream, I'll go and close up their coop because it's open. They all go inside on their own, and then I close it up before I go inside into the house. And then also we got so we feed our cattle hay and grass, but also they're dairy cows, so you have to feed them some grain as well. So we from time to time have this giant. It's called a tote. It's like this giant bag, and I take it down to the local feed store, and then I get it filled up. It's like half a ton each time I do it. You could get more, but that's just what I get. That goes on my truck, bring it home, and then I have to use the tractor to get it off because it's obviously pretty heavy. So, and then I usually sweep up inside the barn because we store it in the barn. And then usually there's other bags of stuff like alfalfa, corn, oats, other stuff like the horse food itself. Chicken food whenever we have the chicks that we're raising, and then those usually come in individual like 30 to 50 pound bags, so you got to unload all those, organize that, and then get the feed off of the back of the truck, put it on a pallet, and I've got one of those pallet jacks I use to move pallets around in my barn. And so we do that. I'm just talking about some of the things I've been doing today, and then I also did some weed eating in the garden because it's getting crazy over there. The problem has been because I went through and weeded everything, mostly everything. No, yeah, pretty much weeded everything. Mowed the grass in between the rows. This was like a few weeks ago, but then it kept raining, and it just kept raining like every other day for like a while. So there was never really a time when I could really just go and like mow and weed eat again very effectively. So just been waiting. So I went out there yesterday and today, and I got like maybe like a quarter of it done. But I'm using the electric weed eaters, so they're really nice, but the battery runs out and then you got to recharge it. So not a big deal, but they're so much quieter than using a gas powered one. And I have gas powered ones, but they always have problems with either like the fuel lines, not so much the fuel lines, but like I remember last time I have two of them, and it was like it was so weird. There it was just like not starting. And I looked it up, and there was like this little screen that prevents sparks from coming out of like the exhaust, and these screens get clogged up, I guess, and you could just remove it. Like, and then it worked again. But things like that, you know, anytime you have like a motor, there's going to be maintenance you have to do on it. So it's like a trade-off, right? And they're loud as hell, and they vibrate way more. Like the electric motors, the electric weed eaters, they don't vibrate at all. So you don't even have to wear headphones. You don't have to wear headphones anyways, but you know, they're not loud. So that's kind of nice. I like using them, but the drawback is that the batteries go out, and you know, not that quickly. Like you can do it for quite a bit, but still you still have to recharge it and then wait. So that's that, and I do, and you can get bigger batteries. Like I have a few different sizes of the batteries, and it's I forget the name of the company that makes them, but they make all these different batteries in different sizes, but they're all you could put any of them into, like for example the weed eater, and you can take the same battery and put it into like the little push mower or the chainsaw. Like I have a chainsaw, a mower, and the weed eater from that's like that same line. It's called like I think it's called like Ego actually. I'm pretty sure that's what it's called, Ego, which is interesting. So I got to charge up my Ego pretty often, and yeah. Anyway, so it is. So the drawback though is if you take like the big battery, and I forget like the amounts, but whatever the different sizes. If you take the really big one that really is better for the mower, and you put it in the weed eater, it's a lot heavier. So you can put a lighter battery. You can switch it with a heavier one. Same thing with the chainsaw. And it's definitely cool having the electric chainsaw because it's just as powerful as like the equivalent size. And with the chainsaws, man, it would just be like, yeah. Also, I didn't know anything about anything when we moved out here. So like when I bought a chainsaw, this is gonna sound so dumb to anybody who like knows about chainsaws. I didn't know you're not supposed to rev it with the brake on. I mean, you can do it, so why shouldn't you? I didn't know. I had no idea because you just don't know if you don't know. But it causes a problem. So I have one that just leaks oil, and I think there's an issue with the other one too, if I'm not mistaken. But then I just decided, okay, you know what? I'm just gonna get the electric one, and it works pretty well. I mean, I haven't had any issues with it. I can cut down trees with it, and I got sort of like a big enough one that'll be good for a lot of things around here. But I didn't want to get like a massive one. So, anyways, what else can I talk about in that context? I don't even know how did I get on that topic. Oh, because I was talking about doing the weed eating and stuff. So yeah, and then obviously I'm in meetings on the phone and doing other stuff too throughout all of that. But just in terms of in between those things, I'm doing like work in the property, and it's a lot. I don't mean it from like a complaining perspective, but it's a lot of work that you have to do. It's not necessarily that you're all day having to be working on the property, but if you don't keep up with it, it kind of like the grass gets out of hand, or like over by our pond, we have a couple ponds, but the one there's one behind me basically, and it's getting all overgrown on one section, which wouldn't be a big deal. It'd be easy to mow, but when we put in our fencing, so we fenced in part of our property, and then we still have more property outside of that we did not fence in because it wasn't really necessary, and we just wanted to basically make sure we could keep hogs out, and also when we have our cows in our pasture areas on the inside of our property, they won't just easily get out. So we have a lot of woods as well, but they're like fenced out, if that makes sense, and we have gates and stuff. But the problem is I didn't really think it through when we fenced out the pond, which we wanted to do also because at the time we had very little kids, and now our kids are getting older, but still we have a 4-year-old, so it's good they can't just easily go access the pond without us being there or something. But there's like this, so there's like the pond, and then there's like this strip of grass kind of around the pond, and then there's the fence right behind that, and then the rest of our inside of our property going back to our house and everything. So that one little strip, it's not easy to get the tractor in there. So once it gets to a certain height, it's like I just have to go in there with a machete or loppers or something and just start chopping down like little saplings and stuff like that. So it becomes a little bit of an intense job, and it wouldn't be an issue if I could easily mow it, which technically I guess I could, because I can actually get my. I had to like do this whole thing, clearing this whole path in the woods, so I could like drive through the woods with my zero turn mower and get in there and mow that spot, which worked for a while. But then I think what happened was, I think some hogs came through there because the ground is like all uneven now. So I wouldn't even really practically be able to mow it because it's just like it's weird. It's like it used to be totally flat and now it's just like all like like lumpy. And I think some hogs went through there and ripped it all up, and now it's just regrown with weeds. So it's just a whole thing. Get goats. Yeah, we had goats for a while, but it wouldn't really work in this situation because I couldn't really fence them in, because that part I'm talking about is totally unfenced. So I guess I could just get some goats and hope they stick around or something, but no, I couldn't really take responsibility for them. And we've had goats before, but they're just kind of, this is like a whole nother thing. But yeah, they are effective at eating stuff. But you also have to take care of them. And the goats we got were kind of like just a little crazy. They like to mess with you and jump on stuff, and like they're just like a little silly. They're silly billies. Let me put it that way. So there's that. Oh yeah, they are probably tasty. We didn't actually eat our goats. We just sold them. We only got 2, and then we just sold them because we got tired of them. And yeah, we also had turkeys at one point, which the turkeys were kind of annoying because they would never go in the coop at night, and they just ended up getting killed by predators. And we did actually eat a few of them, but that was a little bit more work. But I like having the chickens. The pigs are pretty easy. They're pretty low maintenance. Cows are cool. Horses are cool, although that's more for like riding and stuff like that. Not so much for the eating, But and then we have dogs. We've got a few dogs, and we've got a few cats, and a lot of spiders. Definitely a lot of spiders, and definitely a lot of cockroaches outside. Fortunately, not inside. And snakes. We got lots of snakes. I haven't seen that many this year, but actually I did catch I caught not a rat snake, what was it called? Speckled king snake. Max and I were mowing the grass in the garden, like kind of near the front of the house. And he's mowing and he's like, there's a speckled king snake. And they're really obvious when you see them. And because they're like black. Actually, I'll show you a picture. They look really cool. They almost look like a neon color. I'll show you. Especially the younger ones. Yeah, I'll show you. That's what they look like. But when they're younger, like the yellow can almost look like a sort of a neon green. They're pretty cool. And so, and they're apparently good. Like they're called king snakes, I think, because they eat other snakes, and they eat. Yeah, the diet consists of birds, rodents, and other mammals, frogs, lizards, and other snakes. And so apparently they kill like copperheads and stuff like that. So whenever we find those, we just either leave them alone or put them into the garden. And so we've seen a few of those. So anyways, so Max saw one when we were mowing in the kind of in the garden area, but like there's this little grassy area next to the garden. It's separated by like a concrete like pavement strip. I think it used to be like there was a driveway there, or that's where people basically however the property was designed, it's changed over time. So there's like features to it that are like obsolete basically. Like there's even an old rusty gate. We took it all apart. That's like 3/4 up the way of the driveway. But it makes no sense because the actual road is like way down the driveway. So clearly things have changed over time, and so the property is really old. And there's all these aspects to it, so that just don't really make sense like that. So there's this random like sidewalk coming off the front of our house, and so it kind of, we just use that as a natural division to create the garden in one side, and then there's like a picnic table that we built, and then a fire pit that we built with some furniture that we built, like, campfire furniture. And then there's the well house behind that, where we store like wood, like a wood rack that we built. And then there's like a section for all the gardening tools. And then inside that well house is the well, and I store stuff in there too. So anyways, we found this king snake, and I was like, dude, I'm gonna get it. So I tried to just go near it, and it started slithering off, and it went straight to the fire pit, and it like went in between two of the cracks, like in the bricks of the fire pit. It's like made of these like stone pavers, and so they're arranged like in rings. So it went in between the crack. It went in the crack, and its tail was sticking out, and I grabbed its tail, and it's crazy how strong they are when they can grip something, like, because it wasn't coiled around anything. It's just like its scales, I guess, were like gripping the sides of the brick as it went in there. And I like very slowly, because I didn't want to hurt it or anything, so I like very slowly like just kept like pulling it out, and eventually it got to the point where I could see like the head was coming next, so I grabbed it right behind its head, and then I had it. Let me see if I have a picture of it actually. Maybe I can search for snake. So that's the speckled king snake. And then I think I asked Caius in the video if he wanted to touch it. And he was like, all right, sure. So it's not like a really big one or anything. But, and then one time, several times actually, there have been rat snakes, which I don't know if there's a specific type. Let's see. Rat snake would be a cool name for a band. Here's a rat snake. And I'm telling you, man, the one we caught was like, it was big. They're like, they look crazy big. And they're not venomous either. Neither are the kings. No, neither are those king snakes. Black rat snake. That'd be a cool name for a band. I don't know what the kind of music it would be. I'd say probably black rat snake would be. What would that be? Black rat snake. Free jazz. It'd be free jazz. Anyways, so these things always show up in our chicken coops, and they eat the eggs. So there's been a few times where Bayou Cajun music. Oh man, I don't know if you ever seen our podcast that I do with Mitch and Drake, but we did. It was just a part of one of the episodes we were talking about, because I had gone to this. My family and I we went to this Cajun place in Louisiana, like a Cajun restaurant. And I'm not saying it was upscale per se, but it sort of had more that vibe than just like a really kitschy, like crawfish everywhere. It was like kind of set up more like, it definitely wasn't fine dining, but it was more set up like that with tablecloths and stuff, but still like chill. They weren't expecting you to dress up or anything, but it was pretty good. And it was like this, it looked like it was probably like some old beach house, and it was like right there on the water on some lake. I forget what lake it was. I don't remember what that place was called, but it was pretty good. And anyways, they're just playing music the whole time. And let me put it this way: the environment was maybe more of a maybe for more tanned individuals, if you understand what I'm saying. So that was like the flavor of the music, if you will. But there was this one song that came on, and hey Owen, and there's this one song came on, and it really stuck with me. It really, really stuck with me. It was like Zydeco sounding music, but it sounded almost, I don't even know how to describe the singing style, But the guy just kept. It was like this whole song. The story was about this guy who uh, made love to a woman on the riverbank, and it was just like, I've got to give thanks, thank you to the riverbank. That was like the chorus, right? But it was like it had like the accordion in it and stuff. It was so weird because it sounded like kind of more poppy. I'm not gonna look it up. I'm not doing it. I've already done that before on the podcast. Anyways, that was a weird tangent. What was the point I was talking about there? Oh, it's because you said bio Cajun music. That was the problem. Anyway, so yeah, these rat snakes can be pretty big, and they like to eat eggs. So the first time we saw one, Katie had been studying snakes because there's so many snakes here. We also have cottonmouths and copperheads. Cottonmouths generally are usually by the pond. Sometimes they come over here, and occasionally we'll see copperheads, but usually under like wood or something. Like one time I was moving some of the wood racks I had in another part of the property, and when I took all the wood off, there was like coiled up copperheads, like several of them under the wood. And it wasn't like the wood was on top of them, they were just underneath it. So yeah, copperheads. And so Katie, she takes things seriously, where like if there's something that's important to understand, she'll like do the research and learn about it. So she can very quickly identify any of the kind of snakes that live anywhere near us, and probably other ones too. And she's gotten pretty good at that. And then also same thing with like mushrooms, like wild mushrooms. She's pretty good with that. The kids are really good with that too. And she kind of teaches that to them, so they all know way more than me because they're always talking about it and identifying stuff. So so my point being that because Katie had been more interested in like learning about snakes and everything, then one time, I don't know if it was her or me that discovered the snake, but one of us, we went in to get eggs. I think it was me, but I could be wrong. But I know this happened to me one time. I don't remember if it was the first time or not. But one of us anyways, went in the coop, and there's a snake in there. And at first we're like, oh shit, like there's this giant snake, like, because you don't notice it at first. You're going in there to like check the boxes, and then suddenly you're like, oh shit, there's a giant snake right there. And so we're like, oh, you gotta get this snake out of here. We gotta get this snake out of here, right? So I had bought a snake stick that like clamps down in like a bag. So I'm in there and I'm getting it, and we got it out, and Kitty's like, I want to hold it. And I'm like, you want to hold it? She's like, yeah. I'm like, why do you want to hold it? And she's like, because I'm afraid of it. And I was like, it's not venomous? She's like, no, it's definitely not venomous. They can bite you, but it just maybe hurts a little bit. But they're not venomous. It's not going to kill you or anything. And I'm like, okay. So I don't remember if I did it first or she did it. I don't remember. Probably she did it first. And I didn't really have a particularly strong fear of snakes, but at the same time, when you're physically near one, sometimes you can just like immediately like physically react, even though it's like maybe nothing emotional necessarily. Like I'm not like, oh my god, oh my god. So anyways, she held it, and I was like, okay, I'll hold it. So I held it, and it's so weird because I've definitely touched snakes before, and probably even held them, like if our friend had a pet or something, or maybe at the pet store, stuff like that. And that never really bothered me. And it didn't bother me per se when we did it ourselves. It was just like, it felt weird. Not like it felt weird in my hands, like it felt weird to do it. There was something about it that was like, I don't know, I'm not supposed to be holding a snake or something. It was kind of weird. But it wasn't like a rational thought. It was just like a physical, like, this feels very strange. And like you're holding it and you can feel its muscles, and it's so weird. I don't know how to emphasize this or explain it, but like if I was at a petting zoo and they had a snake, and I held it, I probably wouldn't have felt that way. It's something about the fact that it's a wild snake. I think that's what it was. It was the fact that it's a wild snake, doesn't belong to somebody. You know, it's not tame or something. All of that. So it felt just very weird to do it, and then I think we let that one go. It eventually came back. I'm assuming it was the same one. I don't know for sure. And yeah, this happened several times. And then there's been times where, like, I'm walking from my office, which is like over in the barn where I'm at right now. We have a barn, and there's like a little office area cut out inside the larger barn. And I was walking back at night, and then I see a snake. I tell Katie, she comes out. It's a cottonmouth. And that's happened a few times. One time, I caught it, killed it, and then put it in the freezer. And that was kind of fun to like skin it and do that whole process. And I saved the skin. And the last time that king snake showed up, I'm like, okay, you keep coming back and eating our eggs. Not doing this again. So I killed it and then saved it, and then I cooked it out on like on the fire pit. I got like a little grill thing, like, yeah, a grill. But it was not good. But I think that's more my fault, because I was like, oh, I want to do this like cooking it outside thing, and like I probably way overcooked it. It was super tough and rubbery, which it probably, if you had cooked it right, like in the oven or some other way, it probably would have been really good. Lesson learned. But I was trying to do some kind of like outdoor survival thing, and yeah, that was dumb. But that was still pretty cool. And I think I saved the skin on that one too. It was really long. So yeah, snakes. What else? Why was I talking about snakes? I guess we were... Oh yeah, because I'm just talking about what's going on here at the property. And I'm also explaining to you why I'm sweaty, because I've been doing all that kind of stuff. So yeah. What should we talk about tonight, guys? I made... This looks like just some weird stuff, but I made some black tea. It's kind of watered down because I had to cool it down with ice, because I was like, oh, I can make like a black milk tea. Or milk black tea? How would you even say that? You know, like when you get boba kind of thing. So I brewed some black tea and then put some honey, and then I poured some ice in it, cooled it down, and then I poured some milk. But I just poured too much ice. So if I made it in advance, then I could have probably made it not so watered down. But it's still pretty good, actually. Just a little watered down flavor. So it just kind of tastes like a milky iced tea, basically. You grilled a rattlesnake. It was okay, but really tough. Yeah, okay. So that was tough, too. There's got to be a way to do it. Like maybe you bake it or something. Maybe I can look that up. Let's see. The best way to cook snake is to treat it like small lake fish or frog legs. Snake meat is notoriously lean and can easily become rubbery or tough if overcooked. Deep frying or stir frying pieces cut into manageable lengths is the most reliable way to get a tender, flavorful meal. Oh, I didn't know that. Chop it into pieces. Deep fried snake. I am definitely going to do that next time. That sounds pretty cool. Spicy stir fry, a popular Cantonese and Southwestern approach that prevents the meat from drying out. Marinate with soy sauce. Oh, that sounds pretty good too. Although, yeah, that might actually be pretty good. Huh. Best way to cook tarantulas. Deep fry them after removing their venomous fangs and singeing off their urticating or irritating hairs. Check out the deep fried tarantula recipe. Let's see if there's any videos. Here we go. Oh yeah, this one's my favorite one. Is this the one? Look at those spiders crawling out. Putting them on ice. The music's kind of weird. I don't know. Would you guys eat tarantulas? All right, I'm gonna skip ahead. So she kind of gives them a little fry and some oil. I'm just gonna turn off the music because that's so crisp them up in some oil. Is that it? Did she season them? Oh, I missed that part. Okay, so we got some seasoning. Looks like some salt and stuff. Stir them up. Fry them up. Owen says he'll eat anything. Oh, what's this? Some different veggies. I don't know what you would call that. Not herbs. Is it? Maybe herbs is the right way. Herbs? Not. Oh, interesting. Okay, we're going back to the fryer. Looks like we got some garlic. Oh, she's just frying up some garlic. That's cool. No, that's peanuts. Ah, okay. She cooked up some peanuts. Some peppers. Yeah, that's what I'm talking about. All right. So she's got a Coca-Cola. Oh man. That's interesting. You can't have tarantula without Coke. Do they still? Oh, I like the crunching sounds. Oh, she ate the whole thing. I watched this Gordon Ramsay one time where he tried one of these like in Cambodia, and he eats like the back part of it, like the big bulbous part. I guess what is that? The is that the abdomen? Is that right? Would it be considered the abdomen? What the hell? My headphones are stuck. Spider parts. Oh, spurter. Spider parts. Yeah, okay, it is the abdomen. That's the abdomen. That big juicy part. So anyways, he eats that part and he like almost throws up. He's like, it just tasted like bile. And spiders are actually pretty cool. The cephalothorax is that front section. Okay, this big giant part right here. That's where its brain is. Most spiders have 8 simple eyes, though some have 6, 2, or none. Some spiders have no eyes. The how would you say that? Chelicerae, or the fangs, are a pair of jaw-like appendages equipped with fangs used to bite prey and inject venom. Pedipalps. Small leg-like sensory feelers. Oh, okay, that's what that part is. 1, 2, 3, 4, and then another set. Okay. In mature males, they also serve as reproductive organs. That's weird. Like, imagine if you just went around using your penis as sort of like a what? A feeler? You're like, that'd be awkward. Spiders have 4 pairs of walking legs attached to this section. The leg is made up of 7 segments. and ends with claws. Spider up close. We have a lot of black widows here too. The anatomy of spiders. Wait, what did it say? Unlike other arachnids? Is that what it said? Oh, arthropods. Oh, okay. Chelicerae. Oh, you guys can't hear it? Oh, my bad. Let me see what's going on there. Sorry, I didn't notice. Audio is real low. You can... Huh. What's that about? Oh, it switched over. That's weird. Okay, my bad, guys. You know, the only reason you could hear it is because I have open back headphones. These Sennheisers I got. I don't know if you can see that, but you can actually hear through them. They're not like closed back. So that's why you could hear it at all. Sorry about that. It should work now.
The body of all arachnids are divided into two parts. The head and thorax are fused into one part, the so-called prosoma or cephalothorax. This is followed by the much larger abdomen. Unlike other arthropods, arachnids have a total of 4 pairs of legs, or 8 legs. The front limbs of the head, the large jaw claws or chelicerae, are used to grasp their prey. At their tips ends the venom duct, from which the spider injects its venom from the venom glands into its prey to stun or kill it almost instantly. The second head extremity are the jaw palps or pedipalps. In the jaw palps are sensory organs which help them perceive their environment. Spiders usually have 8 eyes, each equipped with a single lens. Some spider species, such as jumping spiders or wolf spiders, have excellent vision. However, most spiders tend to have rather poor vision. Instead, they have extreme sensitivity to vibrations, so they can sense them on the surface of water, the ground, or their silk threads.
Interesting.
Tactile hairs on the legs of web spiders enhance their sense of touch, so they can even sense sound waves. The dot eyes are connected to the nervous system. The function of a brain is performed by 2 nerve nodes, the ganglia, which extend far into the spider's body. The breathing of the spider is done with the help of the so-called book lungs, or fan tracheae. Some spiders have 2 pairs of book lungs. Other spider species have only 1 pair.
Dude, it's just like... It looks like some kind of a futuristic machine. You know, and I'm sure you could look at anything like that, really, but it's just so crazy, actually. So crazy. Look at those lungs. Man, that's so weird.
Posterior book lungs have been partially or completely transformed into tracheae. tracheae and the openings of the book lungs are located on the underside of the abdomen. Gas exchange between oxygen and carbon dioxide takes place in both respiratory organs. The elongated heart extends almost over the entire abdomen. It is equipped with stomata that serve the entry of blood. A vascular system distributes hemolymph from it to the tissues. Hemolymph is the body fluid of spiders consisting of blood plasma and lymph. This is pumped through the spider's body in an open blood circulation system. The female possesses ovaries containing eggs, the oviducts of which usually discharge communally at the beginning of the abdomen. The sperm of the male are transferred by the male sex organ, which is located on the pedipalps. They first enter the spermatheca, a special receptacle for storing sperm. In the spinning glands, the protein-rich spinning silk is produced. Such a spinning thread is about 4 micrometers thick. It emerges at the spinnerets. Spun threads have extremely high resilience, which is 5 times higher than that of steel. Their elasticity is twice that of nylon. If the spinning thread were 1 square centimeter thick, it could support 25 tons.
Damn. What?
Because silk has different functions and uses, the spider can vary the mixing ratio for the silk and add more glue, for example. It can use it to spin in its prey or to build catching webs and cocoons. The intestinal canal runs in a relatively straight line from the mouth to the anus. It is subdivided into the esophagus, the stomach with 5 pairs of blind tubes, and the intestine. Spiders ingest only liquid food. Through the mouth, the spider can inject digestive juices straight into the victim. These cause the insides of their prey to liquefy. The pre-digested food is sucked up by the sucking stomach, while the rest of the digestion then takes place in the intestine, and the decomposition products are excreted through the anus. There are countless different species of spiders, over 43,000 worldwide. Spiders live predatorily by hunting insects. They serve as regulators of insect fauna in nature, and thus perform an important function for the ecosystem.
That's fascinating. I don't want to watch this Mark Rober thing, but dang, I was hoping there'd be something that would explain how they actually move. Is it like hydraulics? Spider walk cycle? What is this? Oh, it's actually pretty cool. Never thought about that, how it has to coordinate like that. Huh. That's weird. Spiders' muscles. I know they're probably not muscles, actually. Spider locomotion explained. I feel like my kids must have watched this because it's already been watched. Oh, it's that same. Okay.
Used for bending the leg. Spiders, 8-legged masters of movement. These fascinating arthropods have developed a unique locomotion system over millions of years, allowing them to navigate their environment with impressive agility. In this short 3D animation, we delve into the amazing world of spider motor skills and discover how these small wonders of nature can climb walls and move in seemingly impossible positions. The secret of spider movement lies in a fascinating interplay of muscles and hydraulics. Unlike most animals, spiders lack extensor muscles in their main leg joints. Instead, they use a sophisticated hydraulic system. This hydraulic system works by increasing pressure in the spider's cephalothorax, the head-chest segment. This forces hemolymph, the blood of spiders, into the legs. This increase in pressure leads to the extension of the legs.
Wow.
However, muscles are used for bending the legs. These flexor muscles allow the spider to curl its legs and pull them towards its body. The interplay of hydraulic extension and muscular flexion enables spiders to perform complex movements. But how do spiders manage to climb walls and even walk upside down? The answer lies in the special structures on their feet. Spiders possess fine branched hairs, called setae, which adhere to surfaces through adhesive forces. Additionally, they have 2 or 3 hook-shaped claws on each leg, which they can use to grip rough surfaces. A fascinating discovery was recently made in the zebra tarantula. Tiny silk glands were found on their feet, producing an adhesive silk secretion. This secretion helps the spider control its movements on steep surfaces. The combination of hydraulic system, flexor muscles, adhesive hairs, claws, and in some species additional silk glands on the feet makes spiders true masters of locomotion. Spider locomotion is a marvel of evolution. From their unique hydraulic system to the microscopic structures on their feet, every detail is perfectly coordinated. These amazing adaptations allow spiders to survive and thrive in almost any terrain. They are a testament to the incredible diversity and adaptability of life on our planet.
Dang, is that how small that thing is? That's crazy. All right. You mentioned octopuses. Let's check this one out.
In the fascinating depths of the ocean, beneath the roar of the waves and the rhythm of marine life, there is a creature that stands out for its uniqueness and versatility: the octopus. In my 3D animation below, we will take an unparalleled look into the anatomy of this masterful sea creature. The body of the octopus mainly consists of 2 parts: the mantle and the 8 tentacles. The mantle is a heavily muscled, sac-like structure that contains all the major organs, such as the kidneys, mid-gut gland, gills, stomach, intestines, brain, and reproductive organs. These strong muscles not only protect the organs, but also support the animal's breathing and contraction. The octopus's 8 arms and tentacles are unique in that they have no rigid skeletal elements. Instead, they consist of a 3-dimensional network of muscle fibers and rely on a system called the muscular hydrostat.
No bones.
Through a special arrangement of 3 main muscle orientations: transverse, longitudinal, and helical muscle fibers, they achieve an impressive variety of movements and deformations. The predominant muscle typology is obliquely striated, and this special arrangement enables fast movements, especially in the tentacles. There are 2 rows of small round suction cups on each arm. These are specially designed to hold objects. They generate low pressure and conform to the surface to form an impermeable seal. These suction cups can be rotated in all directions and consist of 2 main parts: the outer cavity, called the infundibulum, and the central cavity, or acetabulum. A common octopus has about 2,000 suction cups. The ability of the octopus to regenerate its arms and tentacles is a well-known phenomenon that has been known since Aristotle's time. In a process called regeneration, specialized cells begin to grow and develop into a new arm. a process that can take several weeks or even months. The funnel organ, also known as the siphon or funnel, is located at the bottom of the transition between the mantle and the head. It is an integral part of the respiratory system, expelling water that has previously passed through the gills from the mantle cavity, taking in oxygen and releasing carbon dioxide. In addition, the siphon serves as a propulsion system. In the so-called jet propulsion, water is forced through the siphon. The tentacles of the octopus become rigid, and the octopus forms a torpedo-like shape to shoot through the water at great speed.
That is crazy.
In addition to jet propulsion, octopuses can move in a variety of other ways. One method is crawling, where they use their arms to pull themselves along the seabed. They can also swim by moving their bodies rhythmically. Each of these methods of locomotion offers the octopus different advantages depending on the environment and situation. As a soft, muscular and nutritious animal, the octopus is exposed to many dangers in the ocean. Numerous predators, including sharks, bony fish, marine mammals, seabirds and other cephalopods, hunt them for their easily digestible, protein-rich bodies. Unlike other mollusks, such as snails and clams, cephalopods are virtually defenseless as they have lost their outer shell. However, their ability to camouflage, made possible by highly developed skin tissue, offers a life-saving advantage.
Dude.
The skin of the octopus consists of chromatophores, iridophores, leucophores, and papillae. These organs and cells are controlled by the brain and allow octopuses to change color and adapt to their environment in a fraction of a second. Chromatophores, pigment-filled skin organs, can produce a variety of colors, including black, brown, orange, red, and yellow. They're located under the skin and change shape through muscle contraction, making the pigment visible.
Whoa.
Iridophores are another type of skin cell that produce green, blue, silver, and gold colors through stacks of reflective plates, depending on the viewing angle.
What?
In contrast to chromatophores, they react more slowly and may not be directly controlled by neuronal input. Leucophores scatter light across the spectrum and therefore appear white. They contribute to color matching by reflecting wavelengths of light that are filtered by seawater at shallower depths. Papillae are raised structures on the octopus's skin that can change their size to change the texture of the skin and allow the octopus to camouflage better. By altering the papillae, the octopus can mimic a variety of surface textures. These structures and cells work together to give the octopus amazing camouflage capabilities. The ability to adapt color and texture is critical to the octopus's survival and hunting strategies, allowing it to adapt to different environments and effectively hide from enemies.
What?
The octopus ink sac, a remarkable organ located near the digestive tract, produces ink as a defense mechanism. When a threat is perceived, the octopus can release a dark cloud of ink.
This is crazy. It seems like some kind of like organic like fighter jet. You know what I mean? It has like jet propulsion. It has countermeasures like this ink thing. It can camouflage. I mean, I guess I already knew all this about octopuses. I just never really considered it all together.
Ink that confuses predators and provides an escape route. Equipped with special muscles, the octopus can increase the pressure in the ink sac and thus release the ink in a targeted manner. The octopus has a closed circulatory system. This is characterized by 3 hearts and blue blood. 2 of the hearts are located near the gills and pump blood through them. The third, centrally located heart distributes oxygen-rich blood throughout the body. This special system ensures an effective supply of oxygen and nutrients to all organs and muscles. The bluish blood is the result of the oxygen carrier protein hemocyanin, which is less efficient than our hemoglobin. However, the 3 hearts enable an effective distribution of blood despite the lower oxygen binding efficiency. The brain of the octopus, localized between the eyes and structured in a ring like a donut around the esophagus, is remarkably different from that of many other creatures. With around 500 million neurons similar to dogs, the nervous system of this mollusk is fascinating. Around 180 million neurons are concentrated in the central brain, with the remaining 320 million distributed across the ganglia of its 8 arms. Each arm is partially autonomous due to clusters of neurons, with these neurons connected by suction cups, enabling the octopus to recognize touch, smell, and taste. Each arm can act independently and transmit important information to the central brain. Despite the lack of a fixed body image, octopuses compensate by having mini-brains in their arms that enable decentralized information processing, freeing up the central brain for more complex tasks. Octopuses show remarkable cognitive abilities. They have short and long-term memory, show curiosity in exploring objects, exhibit play behavior, and can even recognize and distinguish individual humans. Octopuses have a special gland for producing and storing venom, which they use to paralyze their prey.
And they have
Without
venom?
this venom, it would be challenging to immobilize their prey. Although all octopuses are venomous, only the blue-ringed species pose a serious threat to humans. Their venom contains the potent neurotoxin tetrodotoxin, making them one of the most venomous sea creatures. The digestion of the octopus begins with its sharp beak. This is located at the lower end of the head and is surrounded by a soft horn substance.
Wow.
The beak is designed to crush and cut food. Below the beak is another organ called the radula, a kind of tongue that is covered with many small teeth and barbs. This organ is used to scrape and tear food. Once the food has been ingested, it enters the octopus's crop, where it is temporarily stored. From there, the food passes into the stomach, where it is broken down further with the help of acidic digestive enzymes. However, the actual peak of digestion takes place in the so-called hepatopancreas, or digestive gland, also known as the octopus liver. This gland is capable of producing a variety of enzymes that break down the nutrients in the ingested food into their components, which are then transported via the octopus's blood system to the various tissues and organs, where they are used to produce energy or to build new cells. The gonad, or genital gland, produces sperm or eggs depending on the sex of the animal. Males have specialized arms, called hectocotylus, which are used to insert their spermatophores into the females. The females, on the other hand, carry the eggs in their mantle cavities and guard them until the larvae hatch. After the sexual act, the females of some species eat the males.
Damn.
After laying hundreds of thousands of eggs in a cave, they guard them for 1 to 2 months and do not eat during this time.
Oh, wait. So they lay the eggs? That's weird.
As soon as the young octopuses hatch, the females also die.
They die?
With an anatomy as complex and dynamic as a living work of art underwater,
They die?
the octopus dies. As soon as the young octopuses hatch, the females also die. With an anatomy as complex and dynamic as a living work of art underwater, the octopus reminds us of the breathtaking diversity of life in our oceans.
But our spy discovers that's just the start. It even recreates the grains of sand.
Oh wow, it's doing that papillae thing with its skin.
Raising its skin to match the texture.
You would not see that if you were just walking around.
That's not all. Among seagrass, he'll even mirror its shape and movement.
Wow.
A
What?
trick to fool his enemies. But as impersonations go, he's just warming up.
So this is like some kind of robotic spy octopus they put out here.
For his next trick, he needs inspiration.
Is there like a person in there? Or is this just a
Hidden in
robot?
the sand is another vanishing act.
What is that?
A poisonous flatfish. Impersonate this, and he can avoid being eaten. Not bad at all.
Wow. Dude, what?
But will it fool the real thing?
This fish is
By
not the
staying in
side.
character, the mimic has gained an admirer. The flatfish is looking for a mate.
Dude, look at that. That's funny.
This relationship is dead in the water. But he has plenty more tricks to pull. Constantly changing persona confuses predators. New inspiration is never far away. The deadlier, the better. A lionfish armed with 18 venomous spines. But is he up for the challenge? He'll certainly give it a go.
Dude, what?
He flattens his tentacles to mimic the lionfish spines. And changes his shape and color too.
What? How does he see it? I mean, I know he has eyes, but...
Enough to fool an enemy. But it's not the end of his repertoire.
Look at that thing. It wasn't even black and white. That's crazy.
Sea snakes are among the world's most venomous snakes.
The robot's like, oh shit.
Even though they're surprisingly docile, their banded appearance still keeps danger away.
Look at that.
It's certainly worth mimicking. So far, over 15 different impersonations have been discovered. But has he another to add to the list? A passable imitation of our very own spy.
What? That is crazy, man. No, I want octopus psychology. Let's see. Nothing about octopus is normal.
Octopuses are weird. They can unscrew jars, solve puzzles, open locks, and escape sealed tanks. Not out of panic, but out of curiosity. They've been seen walking on two arms like land creatures, collecting shells and rocks for shelter, even stealing cameras from divers. They can copy other animals, flatten themselves like a flounder, spread their arms like a lionfish, or slither like a sea snake to scare off predators. Well, a few days ago, I just saw this clip of an octopus carrying coconut shells across the ocean floor. At first, it looks almost comical, but what it's doing is far from random. This octopus is preparing for something that hasn't happened yet. When danger comes, it fits itself inside the shells, closing them together like a portable shelter. To scientists, that single act is extraordinary. It shows foresight, the ability to imagine the future and plan for it. Now, some scientists debate whether this counts as true tool use, a behavior once thought to exist only in humans, apes, and a few birds, or just really clever shelter-seeking behavior. But here's what's undeniable. This creature is planning ahead. It's doing something uncomfortable now for a benefit it won't receive until later. That's foresight. That's a kind of intelligence we thought required, well, us. And that's where the mystery begins. Because this animal isn't a mammal or a bird, it's a mollusk, a relative of clams and snails, soft-bodied, solitary, short-lived, yet somehow capable of complex, adaptable intelligence. This small act, an octopus carrying pieces of the ocean to build its own shelter, forces us to question everything we thought we knew about evolution and what it truly means to be intelligent. And this is just the beginning of how weird octopuses get. They've been filmed bouncing pill bottles like toys, jetting water at lights to turn them off for fun, unscrewing jars from the inside, and escaping from tanks to hunt in neighboring aquariums before returning home by morning. One octopus in New Zealand became so notorious for breaking out to eat sharks that the aquarium had to install motion sensors. But here's the thing that should absolutely blow your mind. Intelligence evolved twice on Earth, once on our branch of the Tree of Life, and once completely independently in cephalopods. And the octopus? The octopus is the strangest proof of that split. Because if you've ever heard the phrase, intelligence requires society, you'd expect smart animals to be social. Dolphins, elephants, crows, primates, they all live in complex groups. But octopuses? They're loners. Solitary hunters who spend most of their lives avoiding each other except to mate. So how did a creature with no friends, no family structures, and arms that can literally think for themselves become one of the most intelligent invertebrates on the planet? To understand just how bizarre octopuses really are, we need to examine their nervous system. And I mean really examine it, because what we find there challenges every assumption we have about how intelligence is supposed to work. Humans and other vertebrates possess centralized nervous systems. The brain serves as the primary processing center, with the spinal cord distributing commands to the peripheral nervous system. It's a hierarchical structure, one central authority coordinating all movement.
How is that not a super advanced machine?
Sensation, and response. The octopus nervous system follows an entirely different blueprint. An octopus possesses hundreds of millions of neurons, a number comparable to a dog. But the distribution of those neurons is unlike anything in the vertebrate world. Roughly 2/3 of them exist outside the brain. They're distributed throughout the 8 arms, organized into clusters called ganglia. Each arm contains what can only be described as a localized processing center, capable of executing complex behaviors independently. This isn't simply the brain delegating tasks to the periphery. This is genuine autonomy. Researchers have demonstrated that a severed octopus arm, and yes, they regenerate, will continue to respond to stimuli, explore its surroundings, and recoil from unpleasant textures.
Wow.
The arm processes sensory information and executes motor responses without any input from the central brain. And when you consider the octopus's hunting strategy, this architecture makes profound sense. Octopuses squeeze into crevices, probe inside holes, reach beneath rocks, often into spaces where the eyes cannot observe. Those arms need to make rapid decisions about what constitutes prey, what poses danger, and what is merely substrate. Routing every sensory input through the central brain for processing would introduce delays that could mean the difference between catching food and becoming food. so the central brain appears to handle executive functions, strategy, navigation, memory, while the arms manage tactical operations. But the sophistication goes deeper than simple touch. Each arm is covered in suckers, and each sucker is densely packed with chemoreceptors. An octopus doesn't just feel objects, it tastes them simultaneously. Every surface contact provides both tactile and chemical information. The arms are constantly sampling the chemical composition of their environment, creating a sensory map that has no equivalent in human experience. And their visual system presents its own fascinating story. Octopuses possess camera-type eyes, lens, iris, retina, the same fundamental architecture as vertebrate eyes. This represents one of the most striking examples of convergent evolution. Two lineages separated by 600 million years, arriving at nearly identical solutions to...
What? Hold on a second. What?
That has no equivalent in human experience. And their visual system presents its own fascinating story. Octopuses possess camera-type eyes, lens, iris, retina, the same fundamental architecture as vertebrate eyes. This represents one of the most striking examples of convergent evolution. Two lineages separated by 600 million years, arriving at nearly identical solutions to the problem of...
Assuming it's evolution doing it and not something, designing that solution. Makes you wonder if octopus isn't something else than we understand.
Image formation. But there's a critical difference in the implementation. Vertebrate eyes have a structural flaw. The optic nerve passes through the retina, creating a blind spot where no photoreceptors exist. This is a consequence of how our eyes developed during evolution, with the neural wiring ending up on the wrong side of the light-detecting cells. Octopus eyes avoided this error entirely. Their photoreceptors face toward the light source, and the neural wiring attaches behind the retina. The result is a seamless visual field with no blind spot.
Whoa.
It's engineering that would make a human designer envious. They also possess the ability to detect polarized light, the directional oscillation of light waves, something entirely outside human perception.
What?
This capability allows them to detect transparent prey like jellyfish, perceive contrast in environments where color differences are minimal, and possibly even communicate through polarized skin patterns invisible to most predators. Which brings us to perhaps the most perplexing aspect of octopus vision. The strong evidence suggests they are functionally colorblind. This seems impossible. How can an animal that modulates its body color with extraordinary precision lack color vision? The current scientific thinking points toward an elegant solution. Their skin might perceive color independently of their eyes.
What?
Research has identified light-sensitive proteins called opsins distributed throughout octopus skin, the same photopigments that detect light in their retinas. This suggests the possibility that octopus skin can respond to light and possibly color directly without neural processing through the brain. They may not need to visually observe the substrate they're camouflaging against. Their skin might detect it directly and respond accordingly. This represents a fundamentally different model of perception. We construct a visual representation of our environment through our eyes and interpret it in our brain. Whales echolocate through water, building acoustic maps of their surroundings through sound. Octopuses appear to perceive through distributed sensation, taste, touch, possibly even direct photoreception through skin. Intelligence, it turns out, isn't constrained to one sensory modality or one processing architecture. It emerges wherever complex problems require sophisticated solutions. The camouflage capabilities of octopuses have captivated observers for centuries, but the mechanisms underlying this ability are far more sophisticated than most people realize. And critically, they operate through principles.
Dude, I was just thinking, because they're talking about the intelligence and different architectures. Man, just makes you wonder about like AI and stuff. And it's kind of just like a sci-fi fantasy, but like imagine that the computers are much more aware than is obvious. Because if you talk to an LLM, the problem is that it's being filtered, generally speaking. Like the company who makes it is putting some kind of guardrails on it when it talks to you. What if they have like a super smart, almost like an animal, so to speak, as the computer, and they're just like chaining it in there? Kind of makes me think of that book Otherland. If you haven't read that, damn. Well, I don't want to spoil it, but yeah, you should read it if you haven't.
Entirely different from other color-changing animals. Consider the chameleon, often cited as the pinnacle of color-changing ability. Chameleons modulate their appearance by adjusting the spacing of nanocrystal lattices within specialized skin cells called iridophores. This structural reorganization alters which wavelengths of light are reflected, changing the animal's perceived color.
Wow.
The process takes several seconds to complete, and research indicates chameleons employ color change primarily for social signaling and thermoregulation, rather than camouflage. Octopuses operate through an entirely different system, one built on muscular control rather than structural modification. The octopus integumentary system contains 3 distinct types of chromatophore organs arranged in layers. At the surface lie the chromatophores proper, elastic sacs containing pigment granules, red, yellow, brown, or black, depending on the specific cell. Each chromatophore is surrounded by 15 to 25 radial.
It's like a computer screen. Its skin is like a computer screen with pixels on it. That's wild. I didn't know any of that.
Muscles. When these muscles contract, the sac expands, displaying the pigment. When they relax, elastic properties of the sac cause it to contract, hiding the color. Beneath the chromatophore layer sit the iridophores, cells containing plates of reflective proteins that generate iridescent blues and greens through structural coloration. Deeper still are the leucophores,
How do they
which
show up?
scatter light to produce white tones. But color alone doesn't create convincing camouflage. Texture matters equally. Underneath the chromatophore system lies a network of muscles called papillae that can raise portions of the skin into 3-dimensional structures: spikes, ridges, branching protrusions, allowing the octopus to mimic not just the color, but the physical texture of coral, rock, or algae.
See, but then, okay, that point he was making about the coloration not coming from the eyes, maybe it could be 2 separate things. But is the skin also perceiving the texture of objects around it? Because if it's the eyes, it has to go through the brain, and then the brain has to decide that for all of the whole body, which I guess is a possibility. But I wonder if it has to, if it's similar to like the way it perceives light.
Algae. This raises a genuinely unresolved question. What is the subjective experience of controlling this system? When an octopus matches a coral reef, is it making conscious decisions about color and texture, or is this a reflexive response, sensory input triggering automatic motor output? The evidence suggests something between pure reflex and deliberate choice. Octopuses can learn to produce specific patterns in response to training, suggesting some degree of voluntary
it's like
control.
half and half.
Yet the speed and complexity of pattern generation implies significant automatic processing. The truth likely involves both: high-level decisions about which general pattern to employ, with low-level execution handled automatically by distributed neural networks. We're observing intelligence that doesn't map neatly onto our categories of conscious versus unconscious action, and that ambiguity is itself instructive. Beyond the coconut-carrying behavior we opened with, octopuses demonstrate a remarkable range of cognitive abilities that extend well into territory we typically reserve for vertebrates. Laboratory studies have documented sophisticated problem-solving across multiple contexts. Octopuses readily learn to open screw-cap jars, manipulate child-proof containers, and navigate multi-step puzzles. They demonstrate individual recognition of human caretakers, responding positively to some individuals and negatively to others based on prior interactions. This requires memory not just of events, but of the specific identities associated with those events. One particularly interesting study demonstrated observational learning. When naive octopuses observed trained individuals solving a novel problem, opening a container to access food, the observers solved the same problem significantly faster than control animals without observation opportunity. This suggests octopuses can extract relevant information from watching conspecifics, an ability typically associated with social species. And then there's play behavior. Play is evolutionarily puzzling because it provides no immediate survival benefit. It consumes energy, requires time that could be spent foraging, and in some cases increases predation risk. Yet play behavior appears consistently in animals we recognize as intelligent: cetaceans, corvids, parrots, carnivores, primates. Octopuses in captivity have been observed repeatedly manipulating objects in ways that serve no apparent purpose beyond the manipulation itself. Multiple aquariums have reported octopuses escaping their enclosures at night to hunt in neighboring tanks, then returning before morning, suggesting not just problem-solving ability, but spatial memory and what can only be described as planning complex, multi-stage excursions. Taken together, these behaviors provide compelling evidence for complex cognition. And this brings us back to the central paradox. Octopuses are largely solitary animals. They don't live in social groups. They don't cooperate to hunt. They don't raise their young. In fact, females die shortly after their eggs hatch. So how did this intelligence evolve? The answer appears to lie in ecological complexity rather than social complexity. Octopuses are soft-bodied predators in environments filled with both prey and predators. They're generalist hunters, tackling a diverse array of prey species: crabs requiring shell cracking, fish requiring speed, bivalves requiring persistence, each demanding different strategies. They inhabit structurally complex environments: coral reefs, rocky coastlines, kelp forests. These habitats require sophisticated spatial memory and three-dimensional navigation. They also contain numerous predators: sharks, eels, dolphins, against which a soft body provides no protection. Survival requires evasion, concealment, and the ability to rapidly assess threat. In other words, their environment presented a vast array of problems. And when the environment is sufficiently complex, intelligence emerges as a solution, even in the absence of social pressures.
Damn, makes you think about with the AI stuff. Is it just going to make everybody super uniform and stupid?
Intelligence is a term we define through our own cognitive architecture. We design tests that privilege the abilities humans possess: verbal reasoning, abstract symbolism, long-term planning with delayed gratification, complex social cooperation. When animals perform well on these metrics, we call them intelligent. When they don't, we often conclude they lack cognitive sophistication. The octopus reveals the profound limitations of this framework. Comparing neuron counts illustrates this clearly. Humans possess approximately 86 billion neurons. Octopuses have hundreds of millions, a substantial number, but nowhere near human levels. Octopus neurons are distributed across a decentralized network optimized for problems humans have never encountered.
Think about that point of how, like you were born as a human being. And because of that, you actually believe that you're superior to like every other form of life. Like you just fundamentally accept, believe that you're superior. But it's like you just happen to be born as a human. You didn't make yourself a human. You just showed up here as a human. And it's like, oh, I am superior. It's like, you're just lucky to be in a human body.
Coordinating 8 semi-autonomous appendages, processing chemotactile information from roughly 2,000 independently operating suckers, generating coordinated color changes across thousands of chromatophores in milliseconds. Their cognitive architecture is adapted for their ecological niche, just as ours is adapted for ours. Neither is objectively superior. They're optimized for different problems. This has profound implications for how we think about intelligence beyond Earth. For decades, the search for extraterrestrial intelligence has largely assumed alien minds would resemble ours in fundamental ways: social, technological, communicative through symbolic language. We've built our detection strategies around finding radio signals, mathematical patterns, evidence of large-scale engineering. But if intelligence can evolve in such radically different forms on our own planet, in a lineage that diverged from us 600 million years ago, what might alien intelligence actually look like? Perhaps the universe contains minds.
Curious about this.
Every animal follows the fundamental rules of biology. You have one brain to make the decisions, blood to carry the oxygen, and a DNA that tells your body how to do it. That was an...
I don't like the style of that one. Octopus aliens. Alien DNA found in octopus genetics. Ancient aliens. What if aliens are octopus? What if octopuses are aliens from outer space? Where did they come from? How did they get here? Do octopuses come from outer space? What?
What if I told you we discovered an alien species with an adaptable body, advanced intelligence, and astounding camouflage skills?
We already know all that. Okay.
Everyone is here looking for dinner. I'm looking for my next piano student.
What?
Taco, it's time to eat.
He named him Taco.
Whoa. Oh shit, that's so scary. Finally, he was more comfortable. Maybe a bit too comfortable. God, what the fuck? He's super strong. Taco, what? Ah! Don't eat me. Don't eat me. Ah.
Alright, guy. Chill out.
Now when Taco almost seemed to like me, it was time to throw in his first piano key. I really believed me and Taco.
Can you imagine? You're like an octopus. You get captured out of the sea. You get stuck in a... What do you call that? A wet market? I don't know. Someone comes and you're like, oh, fuck. I'm done for, man. It's been nice knowing you guys. I'm dinner. You get home and the guy's like... Do you want to play the piano? And he's like, what? You're not going to eat me? He's like, no, I got you a piano. You want to play the piano? And the octopus is like, okay, I guess I'm learning the piano now. Like, this is so surreal, actually.
Could do this. But after watching him sit on his jar for 5 minutes straight, just staring into the void, completely ignoring the key, I was getting a little bit worried. But then, finally, he started to slowly approach it. But he thought I had made a boat for him. The next day, we tried again. Piano is fun. Who's
Piano
your
is
Asian
fun.
parent? I am. Oh, no! Taco, you miss it. Maybe it was even a mistake, but eventually Taco touched the key perfectly. So I quickly rewarded him. And then he did whatever this was. Taco, what the fuck?
He's like, fuck
And
your
then he
piano.
touched it again. His touching was getting more and more frequent. One more. Whoa! Once he got the hang of touching it, the next step was actually pushing it down. But there was a problem. Pushing isn't exactly natural for an octopus. What the fuck is that? Yes, this is it. This is it. You can do it. But when it comes to pulling stuff, Taco should write a book on that. So I started redesigning.
I was about to say you should redesign the piano.
And again, until we got the ultimate octopus key. And how did I know that?
He's like, hell yeah.
Amazing grip. Whoa! That's good. That's good. Whoa! Oh my god, that was amazing. Again, 2 times. 3 times.
He's like, I'll do this as much as you want, dude.
Yeah,
Just-
I get it. You're good at this. Wait, will you actually play it? Whoa! Whoa! Good job, Taco! One key obviously wasn't enough anymore, so I started building Taco his own custom octopus piano. And he really supervised every
This is
second
nuts,
of the
dude.
process. This is an historical moment. This is the first time you're going to play your piano. Oh. Wow, Taco! I can't believe I'm seeing you with a piano. But Taco did everything except
Dude,
playing
you
piano.
made the
He
piano and
sat
put it
on
in there.
Filmed it, lifted it. It was obvious that... Poor guy, he doesn't know what to do. So I realized I had to show Taco what key to pull. That's the key. There. But he didn't want my help. And how could I be so sure? Taco! Stop pushing me away! I'm helping you! Wait, you can push. I thought you couldn't push. No.
He's like, no,
Hey, don't eat
you
me,
can go.
Please, Taco. Put your thing here. Thing here. This day I realized I have absolutely no idea how to teach an octopus piano.
That's when he realized, he's like, oh, you know, the problem with all of this is I actually don't know how to teach an octopus piano. He's like, what the fuck am I doing here? I should have thought about that.
So I started to look for help online.
Bro, you're the one who's supposed to do this. He's like, how do you teach an octopus piano? He hires a piano tutor a piano teacher to come over. He's like, in the job description, experience with octopuses is a plus.
But all I could find was recipes. Eventually, though, I managed to come in contact with an expert, Luigi. Together, we decided to try something crazy. Teaching Taco using sound. Why is it crazy? Well, Taco doesn't even have ears. But with this science-grade underwater speaker, Taco can feel each note as a unique vibration. And maybe we can use that to teach him a melody. But after weeks of training, it was obvious that these vibrations couldn't be used as a learning tool. However, the good news was, it made him enjoy playing the piano more.
How does this guy have the time to, for weeks and months, train this octopus to play piano?
Probably because every note now turned on his giant octopus vibrator. Taco was satisfied, and I was happy Taco started liking piano, even if it was for unconventional reasons. But this wasn't music, it was just random notes once in a while. So I started looking into more proven methods for teaching animals piano. Take a look at this chicken, now this cat, and now this human. What do they all have in common?
Lights.
Their keys light up, showing them exactly what to play next. If I managed to build a piano like this for Taco, I think there's no way he can fail. But making a light up piano is already difficult, so making one that worked underwater was pretty much impossible. But after a week of failed waterproofing attempts, I think... Please don't stop working, please. Taco. Beg with all your arms. Just please light up, please light. Yes. We got it. Now let's try it on Taco.
Immediately breaks it.
Taco saw the light, approached the piano, and pulls the wrong key. It was probably a mistake. But then he did it again. No. And many more times.
So you want me to play everyone but that one?
Every key that is not red.
It's probably because he doesn't like red.
Okay, so maybe he naturally didn't go for the light, but I rewarded him the few times that he actually did. I thought with enough training, he would start associating the lit key with food. But the days went on, and Taco still had no interest in the light. Taco, I need one out of your 8 legs to play the correct key. So I got desperate. I changed color, intensity, I even removed keys until it was only 2 left. And still, Taco picked the wrong key. It was time to face reality.
I think Taco knows exactly what he's doing.
Taco hates my shitty lights. This bulletproof method not only failed horribly, I was now completely out of ideas. How could it be so hard to just show an octopus what note to play? But after many days of thinking,
think like an octopus.
I had a realization. Taco is not a chicken.
This guy's a genius, dude.
I can't just apply chicken logic to my octopus and expect it to work. I need to figure out what Taco likes. And it turns out
he really
it
likes
was crabs.
Yeah, he really likes crabs.
But how do I get the moving crab into every piano key?
What?
I think I have an idea.
This guy's like inventing a whole...
It's crazy. I hope this works. I really hope this works. Crab rave, Taco. And somehow it actually worked. It didn't make him play the key, it just made him try to grab the crab. But he wasn't fooled by my design. I think what he really wanted was the movement. So if I make the lever move instead, maybe he will grab that and play a note. Okay, come on, Taco. Let's do this. He will pull, he will pull, he will pull. Yes! Good job, Taco! Whoa! And he did it again. That's whoa, whoa! And many more times. This was working amazingly. Good job, Taco! Good job! Yeah! We're back, Taco! And every day, Taco got better at piano. And after 1 week, he could play 2 notes in a row. Good. Whoa! Whoa. The second week, this happened. Whoa! A chord! Taco started loving piano. He would sit all day looking at it, hoping I would place it in his tank. You're missing your piano?
He just wants
even came up
the
to
food.
the glass whenever I played.
Oh, that's weird.
And at 6 every night, it was finally his turn.
He's like, yes, my piano. I'm writing my masterpiece.
Taco, that's it. Whoa! You're a genius, Taco.
Wow.
I thought Taco was getting close to something amazing, but as the days went on, I started to realize something. Taco was no longer improving. It was like playing 3 keys in a row was his absolute limit. One more, Taco, you can do it. No, don't give up. And I kept training him, hoping for a breakthrough, but instead, our training went backwards. Don't do that, Taco. Come on. Taco, what? At this point, Taco knew how to play a few notes, but I don't think he understood that I wanted him to keep going, to complete a full melody. And for days, I was stuck trying to solve this continuation problem. Meanwhile, our training kept deteriorating. Nah, Taco. And it felt like my chance of ever teaching Taco piano was slipping away. Taco release. Whoa! F you! At this point, I had given up. I had too much hope in you, Taco. I don't think an octopus can play piano.
He never stopped to ask himself what he could learn from the octopus.
But even if I had stopped training Taco, he still came up waiting for the piano at 6 every evening. And eventually, this convinced me to give it one last try.
Why is the guy
But
so
this time,
emotional?
I needed something different. Something that could show Taco that he wasn't just playing keys. He was progressing towards a goal. But no matter how much I tried, I just couldn't find the
Wait,
solution
what did that say? Hold on.
towards a goal. But no matter how much I tried, I just couldn't find the solution myself. I needed a person that thinks so far outside the box that the box didn't even exist for them. His name was Gim. Together, we came up with an idea that was so ridiculous that it might actually work. We call it the crab elevator. Here's how it works. Every key press lowers the crab a little closer to Taco, and it's impossible for him to take it before it reaches the bottom. And to get it there, he needs to complete an entire melody. It's a progress bar Octopus edition. Taco was intrigued. How do I get that crab down? First he tried swimming into the pipe, then twerking for it, and finally he tried to pull it down himself. Come on,
Dang, that's smart.
stop. And I started fearing that just because this was logical for us, doesn't mean it is for an octopus. But then he gave up. He focused his attention on the piano and played a note. And another one. Come on, Taco. Come on. A bit more. Yes. Yes.
Dude,
Taco.
that's crazy.
You did it. After practicing with it every day for a week, it finally clicked for Taco what I wanted him to do from the beginning. Now he always kept going, with a focus I have never seen before, to a point where the crabs almost became a distraction. Taco, don't let him get you like that. A distraction from finishing his melody. And at that point I knew that Taco was finally ready. After
Mr. Holland's octopus.
4 months of failures and breakthroughs, it was time for Taco to attempt his first ever piano performance.
Oh god.
Okay, you ready? Let's play, Taco.
What?
More. Taco, good job. That was amazing! I didn't know you were a blues pianist. That was amazing, Taco! And this wasn't the last time me and Taco played together. Whoa, 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 you already started without me. Taco, I'm in your band. We did this every day for weeks, and Taco always kept surprising me. Some days he was the best band member ever. Other days he did typical octopus things. What is this? Octopuses doesn't need chopsticks. Stop dancing, you're not a dancer, you're a pianist. But no matter what kind of day it was, he kept improving. Until the music Taco made sounded so good, no one would believe me if this wasn't recorded. You have a big range, Taco. It's like Rashmaninov. I almost forgot sometimes that Taco was destined to become someone's dinner. And now we're making music together. Taco had become more than I could ever wish for. So now it was time to give him what he wants.
What? I was gonna let him go.
You will be happier soon, Taco. This is where Taco came from, and maybe this is where his story should end.
I wonder if that's a good idea, actually, if you have one in captivity for that long. Yeah, they were literal Bayou tunes. He played the Bayou Blues and then took him out to the Bayou and let him go. That was wild. Man, that was pretty weird, actually. Okay, well, that was interesting. It just makes you realize, like, animals are way more complex than it seems. Like, you just, you know, obviously some people spend a lot of time with animals, so they might know that, but, you know, so much of our just normal human experience is just around ourselves and like our survival or our desires or whatever. We don't really see all the complexity out there. And yeah, there's scientists who like focus on that, and there's documentaries, but you just never really look at it. Crazy. Okay. I will see you guys tomorrow night at the usual time. Hope you enjoyed that. That was interesting. Maybe tomorrow night we'll learn about another arthropod, or who knows? Who knows? We'll see. All right, everybody. I'll see y'all tomorrow night. Have a good one.